All right, so I'm going to introduce a few more specifics about velocity, speed, and acceleration, just to sort of underline this concept of instantaneous versus average really quick. So let's start with speed. So in order to maintain a constant speed, an object has to be continuously traveling the same amount of distance for each successive interval of time. This means that, so for example, I could have a car that is moving in this direction, and as it moves this way, right, and maybe it's dripping oil, and the oil drips, let's say it drips one oil drip every second, and if the oil drips stay at the same distance apart, then we know that this thing is moving at a constant speed, right? And we could do something similar. Let's say you have a runner going around a path, right? And let's say the runner is, dropping breadcrumbs or something, right? So he's dropping stuff behind him. So he's making a trail. So he drops a breadcrumb every second, and as long as the breadcrumbs, or each breadcrumb is the same distance apart, then we know that the runner is moving around the track at a constant speed. Okay. So 1 crumb per second. Now notice that the runner doesn't have to be going in the same direction, he has to be going in a loop, right? And the direction doesn't matter. As long as the distance traversed by the runner is the same, each second he's going at a constant speed. Okay? Now the car and the person can actually be traveling with the same instantaneous speed as long as at some snapshot of time they have the same speed, right? They're traversing the same distance in the same amount of time. However, two objects can have the same average speed while traveling different distances, different directions, different amounts of time. Okay, so here's an example. Object A is moving at 3 meters per second. Let's say it's going this way. And then let's say we have object B. Object B is moving this way at 3 meters per second. So right at this instant of time, both objects are moving at 3 meters per second. They have the same instantaneous speed, right? Now their speeds may change, right? And as we observe, they may end up having different average speeds, but at this snapshot of time, this instant point, they have the same instantaneous speeds. So let's compare this to something like object A moves east 10 meters and does this in 2 seconds for an average speed of 5 meters per second. And at the same time, object B goes 30 meters north in 6 seconds. So object B would have the same average speed of 5 meters per second. Notice they have different average velocities because they're traveling in different directions. But we have no idea if objects A and B have the same instantaneous speeds at any point in time. They may have, right? They may have both started from rest. They may both end at rest. We really have no way of knowing any further information, but we can conclusively say that their average speeds are the same, right? So while we have no information about the instantaneous speeds while they're traveling, we can in fact conclude that they have the same average speeds. We can do something similar with velocities. So to maintain a constant velocity, you have to keep the same speed and the same direction, right? You can't change your direction. So for two objects to be traveling at the same velocity, you have to go in the same direction with the same speed, but you can have the same, right? That's for the same instantaneous velocity. But you can have the same average velocity and yet have different instantaneous velocities during the trip. And let's examine that through some examples, right? So if A is moving east at 6 meters per second, while B is moving west at 6 meters per second, we know they have the same speed, but not velocity. Right, let me write that a little more clearly. I know it's difficult to read this writing. So if object B is going west at 6 meters per second, we have the same speed, not velocity. All right, now let's say object A moves 4 meters east and then 6 meters west. So, and it does this in a total of 2 seconds. So the change in position is minus 2 meters. So the average velocity is minus 1 meter per second. Now at the same time, object B only goes 1 meter west in 1 second. So the average velocity is minus 1 meter per second. Notice that A and B have very different average speeds, right? A was actually has a much faster average speed than B. B's average speed is 1 meter per second, while A's average speed would be 10 meters over 2, 5 meters per second. So its speed would be 5 meters per second. Okay, so objects can have the same average velocity and yet completely different average speeds, right? All right, let's talk about acceleration briefly. So acceleration is a vector that includes magnitude and direction. So objects can have accelerations of the same magnitude and be moving and changing speeds in different directions. Okay, and that's a little bit weird. It sounds a little bit strange, but I'm going to show you an example. Objects with the same acceleration must be changing speed at the same rate. They don't actually have to be moving in the same direction. Okay, so let's examine that through some examples. So we have object A is moving east at 4 meters per second and accelerating east at 2 meters per second per second. So A is going this way at 4 and accelerating this way 2 meters per second squared. B is moving north 4 meters per second and accelerating north 2 meters per second squared. C is moving west 4 meters per second and accelerating east 2 meters per second squared. And D is moving west at 4 meters per second and accelerating west at 2 meters per second squared. Okay, so all have the same magnitude of acceleration. All four, right? Because all four have an acceleration with a magnitude of 2 meters per second squared. A is speeding up, right? B is speeding up. C is slowing down. And D is speeding up, right? If the acceleration and velocity are in the same direction, you speed up. If the acceleration and velocity are opposite directions, you slow down. But note that A and C have the same acceleration, right? Their accelerations are exactly the same. They're both accelerating east at 2 meters per second squared, and yet A is speeding up while C is slowing down. So it's possible for objects to be going in opposite directions and yet have the same acceleration and be doing different things. So I hope this has helped you conceptualize the difference between instantaneous and average speeds and velocities, and giving you a little bit deeper thought process about velocity and acceleration and what it means to have the same acceleration.